Okay, so we're given this infinite series and we're asked, does it converge or does it diverge? So what we have to do is we're going to do the integral test. So we're going to rewrite it first as an improper integral. Now since, hold up. Here's our issue. We're trying to integrate to infinity. We can't do that. So we have to rewrite it in terms of a limit. So basically this is like a cheap cop-out of instead of going to infinity, we're going to go b. But you know what? B's going to infinity, so yeah, this is like a cheap trick. But it works. So if we look at the denominator here, we see n squared plus 2 squared. So we're going to do some trig substitution. So let's say n equals, let me just pick something off the top of my head, 2 tangent theta. So differentiating, we're going to get dn equals 2 secant squared theta d theta. So what we're going to do is, instead of being an indefinite integral in terms of n, we're going to be an indefinite integral in terms of theta. So what I did here is I replaced n with 2 tangent theta and dn with 2 secant squared theta d theta. So let's do some simplification here. We can take the 5 out, we can factor out a 4 in the denominator, and we can take 2 secant squared theta and put it up top in numerator. So if we recall our trig identities, which I don't remember, actually I had to rederive this, we get tangent squared theta plus 1 is equal to secant squared theta. So let's replace tangent squared theta plus 1 with secant squared theta and see what we can do. So the secant squared thetas, they're going to cancel out. So ultimately what we're left with is 5 times the integral of 1/2 d theta, which equals 5/2 theta. So we got an answer in theta, but we have to convert back to n. It's like I ask you a question in English and you respond in Spanish. It's not going to make any sense. So we said that n equals 2 tangent theta. So we can, if we solve for theta, we can say that theta is equal to tangent inverse of n over 2. So let's take 5/2 theta and rewrite it in terms of n. So we're going to have 5/2 tangent inverse of n over 2. So now that we're back in terms of n, we can apply our limits of integration. So it's going to be from 1 to b. And that's going to equal 5/2 tangent inverse of b over 2 minus tangent inverse of 1/2. So now that we basically solve this integral, we can't forget about the limit as b goes to infinity. And that makes sense because we have terms of b and our original question is in terms of n. So don't forget about our limit as b goes to infinity. So if you think about as b goes to infinity, we're basically going to be plugging in infinity into tangent inverse. So I'm not a mathematician, so I don't really care, I'm going to say this, tangent inverse of infinity. That's going to equal pi over 2. And we can think of it because tangent inverse means, or tangent inverse of infinity means what angle, when we take its tangent, gives us infinity. And if we think about the tangent function, that there's a vertical asymptote at pi over 2 and it actually shoots up to infinity. So we can say that the angle when we take its tangent, or the angle whose tangent gives us infinity, is actually pi over 2. So when we apply the limit, we end up with 5/2 pi over 2 minus tangent inverse of 1/2.